Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the third question, guys, where I'm tackling questions on rates of reaction. Uh, Please do note that there will be a total number of 11 questions that will be answered, and each and every one of those questions will have their own unique video. And secondly, all of these questions, guys, are extracted from past exam question papers. It's very important for you to know how to tackle past exam questions because it will give you an edge whenever you write your exam. So please do share the video to your peers so that they may excuse me, so that they may have the same edge as you. Okay, we are told that the graph below represents the decomposition of gas P according to the following equation. So the gas P will simply decompose into both Q and R together. And our forward reaction over here of the decomposition reaction of P is exothermic, and I'm saying that it's exothermic because the change in enthalpy is simply less than zero. Are you together? If my enthalpy was greater than zero, I was going to say this reaction is endothermic, but since it's less than zero, that's why it is exothermic. Okay. Since we are given the graph that shows the concentration versus time of P, it simply means that initially that was the concentration of gas P. Are you together? And obviously as time progresses, remember that, guys, P will be used up to form both Q and R. That's why the concentration keeps on decreasing as time progresses. Okay, so right now I want us to find the initial concentration of gas P. How can we do that? I want to know that I want to know the value of each line over there. Are you together? For me to be able to find the initial concentration of gas P. So the value of each line, for me to find the value of each line, I simply need to say 0.05 minus 0 all over 10. Why am I dividing by 10? Because I have 10 lines over there. Are you together? And then this will give me 0.005, or you'll simply get 5 times 10 to the power negative 3. That's okay, guys. Ne? The aim is to find the initial concentration of P. So for me to find the initial concentration of P, all I have to do is to simply say 0.25 plus 0.005. This value over there will simply be 0.255. Then I'll have 0.26, and then I'll have 0.265, and then the initial concentration will simply be 0.27 moles per cubic decimeter. So the initial concentration of P is basically 0.27 moles per cubic decimeter. Okay, now let's answer the questions. They want us to define the term rate of reaction in words by referring to the graph below. To the graph name. We will simply define our rates of reaction by saying rates of reaction is basically the change in the concentration of gas P per unit time. Are you together? The change in the concentration of gas P per unit time. And then now we are being asked that at which time, 10 seconds or 30 seconds, does the decomposition takes place at a higher rate? Refer to the graph to give your reason. Okay, 10 seconds it's over there, and then 30 seconds it's over there. We can see, guys, the difference in the shape of our graph. Over here, guys, our graph is more steeper, which simply means that around 10 seconds, the rate of decomposition of gas P is higher. Are you together? But over there, guys, the decomposition of P is slightly reaching completion. Are you together? So we will have less effective collisions happening around that place. Why am I saying that? Because as time progresses, the number of effective collisions will always decrease unless we tamper with the factors that affect the rate of reaction. Are you together? So as time progresses, the number of effective collision will keep on decreasing. Are you together, guys? And that's why around 10 seconds our graph is more steeper, because we have more effective collisions happening at during time 10 seconds, and then over there we have less number of effective collisions happening. Are you together? That's why over here we have a higher rate of reaction, and then over there the rate of reaction is just lower. The rate of reaction is just lower. Okay, so now I know that at time 10 seconds we have a higher rate of reaction. Now they want us to calculate to write down the initial concentration of P. We did find that the initial concentration is just 0.27 moles per cubic decimeter. That's our concentration. Okay, the decomposition is carried out in a 2 cubic decimeter container. Calculate the average rate in moles per second of at which P will decompose. Since they want us to calculate the rate in moles per second, that means we must know the number of moles initially and the number of moles at 10 seconds. Are you together? But for us to do that, we must know the concentrations. I know that my initial concentration is 0.27, and the concentration at time is equals to 10 seconds is basically 0.15. So I can simply calculate the number of moles. So for me to find initial number of moles, I need to say initial concentration is equals to initial number of moles all over the volume. My initial concentration is just 0.27. I don't know the initial number of moles. Divide by 2. So therefore the number of moles, I'll simply say 0.27 multiplied by 2. 0.27 times 2. This will basically give me 0.54 moles. Are you together? And then the final concentration at 10 seconds is equal to the number of moles final all over the volume. I have 0.15 all over the number of moles final. The volume is still 2. So the number of moles at t is equal to 10 seconds is basically 0.3 moles. Are you together? So therefore the change, or let me just say the rate of reaction is basically equal to the change in number of moles all over the change in time. Are you together? So it will be the number of moles final minus the number of moles initial all over the change in time. That's 0.3 moles minus 0.54 all over 10. So this will give me I'll simply have 0.3 minus 0.54 all over 10. This is basically 0.024. It's negative. Are you together? Don't worry, guys, about the sign over there, né? Because the sign just tells you that you are dealing with a negative slope over there. So basically the rate of reaction, I don't have space, man. Let me just write the rate of reaction is basically 0.024 moles per second. Always the time, guys, your answer should end with per second. So that's how I was supposed to calculate my rate of reaction. ROR is basically 0.024 moles per second. Okay, now I'm supposed to draw the potential energy diagram for the reaction, and I must clearly indicate the following on my diagram. The potential energy diagram. Remember that, guys, I have an exothermic reaction now together. So the heat of my reactant should be greater than the heat of my products. Are you together? So this over here will represent the heat of my reactants, and then that over there will simply represent the heat of my products, and then the difference between the two will represent the change in enthalpy. Heat of the products minus the heat of the reactants. And yes, I'll simply get a negative answer. What did they want me to indicate over there? The position of the reactants and products. Okay, yeah, that's my reactants, and then my products, that's 2Q and R over there, and then the activation energy of the forward reaction. Let me indicate it in black. Activation energy is over there, now guys. The minimum energy required to activate the reaction. Okay, and then now I'm being asked, an increase in temperature will increase the rate of decomposition of P. Explain the statement in terms of collision theory. Whenever guys, you increase the temperature, what will happen is that you are increasing the average kinetic energy of the particles. Are you together? And whenever you increase the average kinetic energy of the particles, we'll end up having more effective collision. Are you together? Remember that, guys, for us to increase the rate of reaction, we must have effective collisions. So now I know that whenever I increase temperature, the average kinetic energy will simply be increased, and hence my particles will be obviously correctly orientated, and then I will have more effective collisions. That will result in a higher reaction rate. That's how, guys, we're supposed to tackle that question over there. So just stay tuned and wait for more videos. Thank you.